Question B2. This question is about radioactive decay. A nucleus of the isotope iodine-124, proton number 53, may undergo positive beta decay to a nucleus of an isotope X. State the nuclear reaction equation for this decay. Now, positive beta decay is when an electron is formed. So basically what happens is that you get a proton and it turns into a neutron plus an electron. So we see this is positive, so you get your charge remaining the same, you get conservation of charge. So in doing this, we have our iodine here, this iodine-124. This is the nucleon number or the mass number. This is the number of protons and neutrons, or we usually use Z for protons, like that, and that's equal to A. That's the number of nucleons. So that's 124. Now basically what happens here is that you've got 53 protons to start, but you actually get a decrease in the number of protons. One of these protons actually turns into a neutron and a positive electron, so it actually goes down to 53. So you'd get something like this. You would get your iodine, that's 124 and 53, and it would turn into X. This would be 52, but this would still be 124 because you still got the same number of nucleons. You just got a proton turning into a neutron, but a neutron is also a nucleon. Plus, you're going to get your beta plus, or your electron, your positive electron, plus your neutrino, your regular neutrino. So that would be your nuclear reaction that you would have. Then it says in B, the half-life of iodine 124 is 4.2 days. So the T half-life is 4.2 days. A freshly prepared sample of isotope has an activity of 810. Back wheel. This is your A0. This is your starting off activity. Determine the activity of the sample after 6 days. So in doing this, we're going to need to do two things here. We are going to be working with our activity here. Now, this formula here, this lambda n0 is actually also your A0, where your lambda is your constant, is your decay constant, and we can work that decay constant out from this. So basically we're going to firstly find our lambda. So our lambda is going to equal the ln of 2 divided by our half-life, divided by 4.2. That will give us our lambda. So let's just work it out quick. We'll bring in our calculator. So this is the natural log. So we're going to get here, we're going to get our natural log. So that's ln of 2 divided by 4.2, enter, and we get 0.165. So our lambda is equal to 0.165. Then going back to our formulas here, we're going to use this formula over here. Let me just rub this out because I've just gone over there. So we'll put this in here. Let me just work over here. So we're going to get our activity is equal to our activity 0, which is 810 times E, and we're going to get minus 0.165 times by my time, which is after 6 days. So it's times 6, and that will give me my activity. So let's bring back the calculator here. Alright, so we are going to first see, so it's going to be 810 times, now I'm going to put in my E there, and I'll put this all in brackets. So this is going to be minus 0.165 times 6. Now close brackets on that, enter, and it will be 300.97, so I'm going to say it's going to be 301 would be your activity after that time. So it's going to be 301.0 if we wanted. Let's just have a look. It's three significant figures, or even two significant figures. So definitely 301 would be fine, and that would be back well.